Hi class, let's take a look at the assignment I posted this morning, which was the addition, subtraction of numbers in scientific notation. I left the link for you to go back and review a video that I posted last Friday on doing just this. All right. Let's just jump right in from problem 1A. All right. We have an addition problem, 1.2 times 10 to the 5th. And we're going to add to that 5.35 times 10 to the 6th. Right. One number in scientific notation being added to another. What we need to be checking, this is true of subtraction also, is that these have to be the same. And if they're not the same, we've got to fix it and make them the same. All right. One is an exponent of 5 and the other is an exponent of 6. Right. What I will typically teach my students is to choose the highest of these exponents, all right, the 10 to the 6th. All right, we're going to keep this number the same, but we're going to have to modify this one. All right, so this number is going to be changed to 10 to the 6th power. All right. Well, that has an effect on the front bit, all right. What I typically think about when I'm doing this is exchanging value. I need to go from 10 to the 5th, 10 to the 6th, which means I'm making the back half of this number bigger. So that means I have to make the front half of this number smaller. I'm borrowing value from the 1.2 and putting it on the exponent. To go from 5 to a 6 means I need to make the back half bigger. I'm going to make it bigger by borrowing from the smaller. If I make this 0.12, in other words, I move the decimal point over one place to the left, I've got my answer. I've made my exponent bigger, I've moved my decimal point one place to the left and made the number in front smaller. All right. So now I've got a problem that I can do. I could add numbers in scientific notation when the exponent on the 10 are the same. Right. I think the easiest way to do this is set this up just like you would any addition problem, writing it in column form. And when we add numbers in columns, we always line up the decimal points with each other. All right, so here's the question that we have right here. What is the sum of 0.12 times 10 to the 6th added to 5.35 times 10 to the 6th? Well, on the back half, we just bring this exponent down. That's why they need to be the same. This is 6, this is 6, it's 10 to the 6th in the answer. If they're not the same, we can't just drop it down. So they have to be the same. All right, now we go to this side and add it together as if it were just a regular old addition problem. All right, 2 and 5 is 7, 3 and 1 is 4, 0 and 5 is 5, the decimal point right there. Right. 5.47 times 10 to the 6th is the correct answer. Now, is it to the correct number of sig digs? Well, the rules for addition and subtraction tell me to look at the position of the last sig dig in each of the numbers I'm adding. The 2 is the last sig dig here, it's in the hundredths place. The 5 is the last sig dig here, and it's also in the hundredths place, which means for my answer, I want it's the last sig dig also in the hundredths place, which I have here, so I don't have to do anything to this answer. It's 5.47 times 10 to the 6th. All right. And I'm going to go ahead and do part E of the homework. 8.41 times 10 to the minus 5. I'm going to subtract from that 7.9 times 10 to the minus 6th. Now, I have it set up like this. Can I go straight ahead and do the subtraction? Now, what you're looking for here is for addition and subtraction that the exponent part of the number has to be the same. And they are not the same in this case. So what should we do? Should we change the -5 to a -6 or the -6 to a -5? We can do either. Again, what I typically teach to my students is choose the greater of the two exponents and make them all the same, and make them that number. Well, what's greater, -5 or -6? Think about the negative side of the number line. Which one of these two numbers is closer to 0, right, as the greater value? Well, -5 is the greater value. So that means I want to change this number to some number that's times 10 to the -5. Right? Just for the heck of it, real quick, let's do that work down here. Right, 7.9 times 10 to the -6. I want to make it 10 to the -5. What have I done in going from -6 to -5? I've made it bigger by 1 decimal place. I need to borrow value from the front part of the number and tack it onto the back half. If I'm going to make it a bigger value in the back, I have to make a change up front, which makes it smaller by 1 decimal place. Right. What direction do I move the decimal to make a smaller number? Well, if I move it this way, I'm going to end up with 79. I don't want that. I want 0.79. Right. To make numbers smaller, you move the decimal point to the left. Right. So this is the number that I want to put back upstairs in this original problem. So let me erase this and go back. Say I want to subtract from this 0.79 times 10 to the -5. That's the problem I want to do, or that's the problem I can do. All right. The 10 to the -5 just drops straight down. Right, that's why they have to be the same. So that's the way this works for addition subtraction. Right? And I just carry out the subtraction on this side as if it were just any old subtraction problem from like back in 4th or 5th grade. All right. 1 minus 9, well, I got to borrow. All right, I'm going to borrow 1, so this will be 11. 11 minus 9 is 2. All right, now this is a 3 now because I borrowed from it. I got to borrow again. So it's 13 minus 7 is going to be 6. Don't forget I borrowed from the 8, so that's going to be 7. It'll be 7.62 times 10 to the -5. Now, how many sig digs should I have in my answer? Well, I go back up to the numbers that I subtracted in this case and look for the position of the last sig dig. All right. The 1 is in the 100th place. Over here, the 0.79, the 9 is in the 100th place. So I want my last sig dig to be in the 100th place. So this answer is just fine the way it is.